So thank you for dialing in. I see several old friends there, Corey, Krish, various others. Thank you very much indeed for dialing in, Simon. What you'll know is, those who know me, I'm a chemical engineer with a long background in mechanistic modeling, process simulation, looking for the detailed way of doing things. I've increasingly been working on well, I've always worked to try and apply that knowledge to help improve existing facilities and how they operate. And so today, what I'm going to talk about is some of the recent stuff that we've been doing at Crowley Carbon that sort of melds together that detailed expertise with mechanistic modeling, and most importantly, linking it all together with a tool we call Clarity, which is a web-based or a cloud-based platform that consolidates data from a bunch of different systems and then allows you to interrogate and work with that in a bunch of different ways. So the seminar's called Spinning Straw into Gold. I guess that makes me Rumpelstiltskin, so I probably shouldn't have mentioned my name at the start. But I'll try and come up with something useful such that you don't call me out later on. So sorry, just to give a quick overview of more or less what we're going to be talking about. There have been lots of tools and work processes around, since the industry began, since chemical engineering first came around. People have been trying to work out, how can I run and operate this facility or this set of plants more effectively? And so the question is really, what's new, what's changed? And the answer is, there's not a lot that's new under the sun. There's a lot of things that have always been done. What's changed and what's developed is that things are becoming much more connected, much quicker, much easier to consolidate and bring it all together. And so what I'm going to try and do over the next 30 minutes or so is talk a little bit about how to exploit that knowledge and how to exploit that availability of both knowledge, skills, and data to try and spin something more useful out of that morass of data that you sometimes have. Today, and today is still true in many companies, what you end up doing, particularly as the company grows, you start having multiple different areas of expertise and speciality. You have people who really focus in on reactor design or separations processes. And if you're a big company, like the multinational petrochemicals or chemical companies, you can afford to have 10, 15 people whose full-time job it is to work out how best to save energy or how to run a distillation column most efficiently. But in smaller companies, that's sometimes difficult to achieve. And even in those big companies, what you end up doing is you end up having these process experts who are really, really good at what they do, but they start developing a bit of tunnel vision. They start solving their problem to a really high degree, but maybe losing sight of the bigger picture. So your distillation column gets absolutely perfect separation, but it's maybe using more energy than it really needs to. Or your reactor yield goes up substantially, but you're causing problems for the wider system. So a lot of opportunities that I've come across through my career have been in trying to pull back and look at that bigger picture, draw the knowledge from the individual experts, draw the data from the process, and try and synthesize that together into something that can really be leveraged into value. At the end of the day, most companies are in business to make money. If they can do that with a lower carbon footprint, with lower energy and all the rest of it, that's great. But if they're not making money, they're not going to survive. So you need that bigger picture, the way all the different focus areas fit together to be able to really focus in on how to make a difference. So if you look at the way that works, you often have, and indeed Crowley's history is around energy minimization. Energy is a nice independent system. You can often carve it off and look at various aspects of how energy works independently. It clearly does interact with the process, and so there's opportunities there. But you can really get deep into expertise in refrigeration systems or boiler systems, compressed air, and really build a good knowledge. Increasingly, that energy is also being pulled back out to understand carbon footprint and environmental sustainability. But right next to energy is yield. Most plants, if you look at the cost of operating most chemical engineering facilities, the top three costs are raw materials, capital, and people, and then energy is in there, usually sort of 4 or 5. down the list. So with yield, if you can get a couple of tenths of a percent more product out for the same amount of raw materials going in, you can have a huge impact on your economic footprint. And increasingly, depending on how you do your accounting, that improved yield also translates to an improved carbon footprint or environmental footprint. Capacity and reliability sit side by side often. They're very much focused on how can I make the most with the capital that I've got? How can I drive my maintenance costs down? How can I maximize my uptime and throughput for my facility? How can I use my capital as efficiently as possible? And there's people who spend careers focused on that and do some really interesting and fun things to make that happen. Quality is another department that's always really important. At the end of the day, if you're not making product to spec, you're going to have to do something else with it. And if you can make it to a higher specification, you can maybe enter a more lucrative market. So you have often a large team, largely dominated by chemists and biologists, who are looking at how to make the highest quality materials possible. And then finally, depending on the type of facility you're running, you may want to also have facilities so that you can take advantage, flexibility, so that you can take advantage of changes in market conditions. So this type of raw material is going to be cheaper to operate. These products are in higher demand, so will command a higher price. Can I retool my facility, or can I rebalance the way I'm running my process to maximize the profit that I can make? So we've got lots of different, this is just 6. There's obviously lots more different aspects of how you're running your facility and what people are interested in doing. But often, as I say, these are set up as independent groups or independent fiefdoms who are pulling data and knowledge from similar areas, but are maybe using different tools and different approaches. Talking of those approaches, there are 3 that really stand out in my mind. One is you go and you find a team of experts. You get people, or you build a team internally of operations and running experience to really understand how your process works, how the equipment at your site works, what you can do to tweak your process to get as much as you can. And if you have people who really understand the fundamentals and the underlying behavior and who have experience with the specific equipment, you can make some pretty great big steps doing that. That doesn't have to necessarily be in-house knowledge. Obviously, you can leverage vendors. That's an increasingly popular option, particularly in some of the ancillary areas like utilities. Or you can bring in consultants for some of those non-core areas to try and really understand how can I tweak up and how can I maximize this piece of my process. Very sexy today is the whole area of data analytics, machine learning, artificial intelligence, statistical analysis. It's an area that 10, 20 years ago was maybe more dominated by, or maybe not that long ago, Six Sigma or total quality, or the idea of going in, looking at the data, using and leveraging your data to really find those golden moments, the best batch or the best operating region that you've ever operated in, and try and reproduce that consistently. Or comparing different plants or different machines, so you can start looking for best practices. What's the best that can be done based on a data analysis? Obviously, these days, as more and more data becomes available and more sophisticated computer tools are applied, you can start doing some really interesting things with artificial intelligence and machine learning. But at the end of the day, those are basically still statistical analyses where you're saying, look, I've got a bunch of data, I'm going to try and reduce that into something that's useful. And then finally, you have the engineering fundamentals. You've got where I spent a lot of my career is trying to sort of reduce the fundamental physics and chemistry down into a clear analysis of a mathematical representation of the mass and energy balance, so that you can start saying, look, given this piece of equipment, this is how it should be working. This is the design that should give me the best yield or the lowest throughput. And so really what you're trying to do is leverage your process design and equipment details to maximize what's going on. So we've got a series of different skill areas, and we've got a series of different tools that people can employ. And I'm sure you've had the experience where you start setting up teams and pulling together data. You have death by spreadsheets where you're desperately trying to consolidate information from 5 or 6 different systems. You've got the team who's focused on quality, are maybe insisting that it makes sense to use more energy, while the energy team is saying, well, no, look, we could save the energy and still meet the spec. Do we really want, which is the right goal? How do I prioritize? How do I balance with the multiple competing approaches, the multiple competing focus areas, and the multiple competing goals? So what we've been trying to do is draw all that information and knowledge together into a common platform, leverage that as much as possible so that you can combine the data with the analysis of the data from experts in reports and dashboards and views to be able to see what's going on, and then really supplement that data with solid, structured underlying statistical analyses and mechanistic models. To try and walk that through a couple of steps, the Clarity tool that is really the core to a lot of what we're doing is a web-based environment where it sits on the cloud. It's looked after by AWS, so it's got all of those high-end security features. It's got all the reliability and cross-reference backup mirroring kind of things, so that your data is safe. It's also really quite secure. I mean, one of the concerns historically with web-based applications is that, I'd rather have the data in a hard drive in my plant, because then I know what's going on with it, and that still has some merits. The drawback, though, is that you need to be able to back that up and make sure that it's safe and stored. If there is an issue at your site, you need to keep the software on that machine up to date and the hardware on that machine up to date. And it starts becoming a maintenance reliability issue as time goes on. The beauty of having the data up on the cloud is obviously as bug fixes and patches and improvements to the software come, as equipment reliability has issues, all that stuff is taken care of independently and can be updated. So Clarity is a really nice platform that we put a lot of time and effort into making it very connectable. So it can hook into DCS, distributed control systems. It can hook into lab information management systems or enterprise resource programming. You can patch it into Excel. You can upload CSV files. You can have it talk to equipment PLCs directly, and so you can pull all the data from all your different sources together into a single consolidated common environment. In that environment, it'll clean up the data, it'll structure it in such a way that you can easily find it and understand what's going on. And then you can adapt and supplement the data. One of the really powerful features of Clarity is that it lets you put in calculations fairly easily. So you can go in and change or supplement the data with analyses. So you have, for example, maybe a density meter that you're using to calculate a concentration, where you can have that density reported directly, and then you can build in the correlation to say, and so this is the concentration that corresponds to. Once you've got all that data together and you've cleaned it and you've got the ancillary data put together, you can then start applying it. So you can build dashboards, and depending on the user, different people will be able to see the same data but in different forms. You can build reports that consolidate not just the data and the graphs of how it's performing today, but also structure the data in such a way that it becomes useful and easy for people to then report up. So if you're doing, I don't know, environmental reporting, it gives you the data in the right form such you can just copy and paste or email it automatically out. You don't have to spend the painful time of pulling data together into Excel and then cleaning it up and then posting it. It can handle that sort of reporting for you. And then finally, it can also, well, not finally, it does more than that. It'll also report and alert you. So it'll pay attention to something. And if you say, hey, look, if the boiler pressure goes below this point, please let me know. So you obviously have your operators have their own alarms for critical issues, stuff that they need to pay attention to. But maybe as the site manager, you want to be able to get told if there are issues with something. And so you can set it up such that it'll alert you and warn you and give you the data and the information that you can then drill down and try and understand what's going on. Running parallel to that, we have a team of which I'm part, where we're doing that detailed mechanistic and engineering modeling. So we're pulling in the equipment specifications, the design sheets, the physical property, the underlying chemistry, and the mechanistic performance. Bringing all that together, that'll typically go into the engineering cycle where you sort of conceptualize and ideate, come up with new ideas. You can do the detailed design, do the operational support, and then redesign or improve your process. That obviously spits out things like mass and energy balances, techno-economic analyses, optimal performance, pinch analysis. So you can say, look, with this design, if I can use the heat from here, I can supplement what was using steam, I can do with the process stream instead. And I can also then build out engineering packages so that as I make recommendations for how to change the process, you can build the data sheets that are required to go and do the more detailed analyses. So historically, those have been sort of separated streams. Increasingly, what we're doing though is pulling the data out of Clarity, well, increasingly within Clarity, but also for some of the more sophisticated analyses out of Clarity, so that you can trim up the data, clean it up, send it through complex statistical packages, and find new correlations. So you can explore the data and troubleshoot it, but it's all there already in clean format. You can build regression analyses, so you can start saying, look, my overall energy use seems to change in this way, at least in the historical data. Let's capture that and then project that forward so that I've got a goal of, look, this is historically how I've done, this is how I'm actually doing today. Is something drifting off? Is something different from how it normally works? And then depending on the environment, you maybe want to start doing some cluster analyses where you start saying, look, this period I was out of spec, this period I was in spec, what's different? How can I understand what's going on? As you do those analyses and as you build those models, you can then take those models, and what's nice about Clarity is it's relatively easy to then put those models back into your data stream, and so that your user interface starts giving you that this is where I am, this is where I could be kind of data, or look, the historical data says we should be here, we're actually here, and that's the sort of thing that might generate one of these alerts or show up in the report, so that it's not just a simple, hey, the boiler's down. It looks like you're using 10% more steam than you did last year. Do you want to have a look? And this is why we think it's happening. The other thing that we've been doing quite a lot of recently, and which I'm really excited by, is this idea of reduced order models and regression analyses based on the fundamental mechanistic side of the work. So we build out in design phase these beautiful complex mass and energy balances, but trying to actually take those models and put them online is a non-trivial task. So what we've been doing quite a lot of recently is statistical analyses, where we run that model, we generate a wide range of data, and then we use regression analysis to convert that complex mechanistic model into a locally relevant correlation. And again, what we can do then is we can take that fundamental knowledge, or the cream of that fundamental knowledge, put it together with the live process data that's coming out of the facility, and then use that to start giving you the trend lines of, this is where you're actually operating, this is where the model thinks you should be operating, and now it's a mechanistic rather than statistical model. But with the mechanistic model, you can then also say, and look, if you operate at the set points that we think are the correct ones, you potentially could be operating here. So you start getting that gap of, have I got any operational maintenance issues that I need to worry about? And then have I got any operational opportunities to change where I'm running and how I'm running the facility? So it's really quite a powerful environment where what I'm doing is I'm drawing all the data I have available from multiple different sources together. I'm analyzing it with both statistical and mechanistic techniques. I'm leveraging the expertise and the knowledge that I have from those experts that I have available to me, and I'm presenting it all in a single environment, such that I've got one version of the truth, so that the people who are looking at the process quality and are worried about qualifying lots and making sure that I get my material out in a timely and correct fashion, are using the same information in the same environment as the guys who are looking to maximize the yield and capacity of the system, and are doing the same as the people who are doing the environmental reporting or the standard reporting in that way. So it really it's quite a powerful set of tools, and I think what differentiates it is it really does allow the subject matter expertise that the people who really know how the boiler works can come in and help you design the key performance indicators, and can design the way in which data is summarized and analyzed to present it back to the users. And then once that knowledge is captured and encoded, it's there and it's available next time you want to have that detailed analysis. Similarly, if you've got somebody who really understands the maintenance side of things and has a look, I really need the information presented in this form, you can build that report out, and then once it's done, it's there and it's available, so it becomes much quicker and easier to report that information in the future. The other thing that's quite fun and exciting is that this same platform can then be deployed across multiple sites. And now, rather than having all the information at a single site, you can start leveraging your knowledge across your whole corporation, your whole organization, and you can start comparing different sites and different ways of doing things. So I think that's the majority of what I wanted to cover. Building Clarity is, as I say, I think what's powerful about it is that it's very well designed to suck data in from multiple different systems, locations, setups, and put them all together, clean the data, archive the data in a good, clean fashion. But then also let you visualize and report that data out. You can calculate your key performance indicators really pretty easily compared to some of the other systems that I've seen. You can pull together graphs and cross analyses in very little time. If you've got standard reports for, I don't know, your environmental reporting or your energy platform or some sort of ISO requirements, you can get all that information together, consolidated, clear, and presented. And then the really powerful thing is you can start leveraging your expertise and your knowledge from other mathematical systems, put those into statistical reduced order models, and tie those directly into your system. The other thing I'll just mention, working with Crowley, I think as compared to some other organizations that I've seen, they have some really top flight in-house expertise in terms of subject matter expertise. So they have people who really understand boilers, compressors, refrigeration systems, all the utilities, and increasingly several parts of key processes as well. And so the solutions that are developed and the interfaces that are developed are put together by people who really have that end user experience, as well as a team of software specialists who can make the software look good. They've also got we've also got the experts to make it relevant and useful as well. Crowley's also got a solid background in project execution, capital installation, and process operation. So there's a very strong focus on safety, reliability, feasibility of making stuff. It's not, hey, here's a bunch of cool ideas, have fun installing them, we're out of here. It's, we've got the experience, the knowledge, the skill to be able to start up and make sure that the process really does deliver value. So it's a really powerful handshake between here's some really good ways to change your process, and here's some really powerful software to make sure that those changes, if implemented, really do what you want them to do and keep working, not just for the first 3 months after they're installed, but for the 5 years going forward as you make changes. And yeah, I think that was the majority of what I wanted to say. I think I'll pause there and see if there's any useful questions. And thank you very much for listening this far.
Charles, a couple of questions there. Can you see the chat there on the right-hand side?
I can't see the chat at the moment.
So Mark Robinson has said, what effort and cost is required to regress the mechanistic model to link to Clarity? And is the cleaning up of data automated in Clarity?
So those are two separate questions. So how much effort is it to reduce a mechanistic model and turn it into a reduced order model? That is, unfortunately, that's a how long is a piece of string kind of a question. It really depends on how complex the model is and how reliable and secure, or how well the model converges normally. If the model is fairly robust, what we've done is we've built automated tools that will run that model multiple times. There are statistical techniques that you can use to what they call space filling designs. So you can have a multivariant. You can have 10 or 15 different inputs. You can say, given these 10 inputs and these ranges on those inputs, please design for me the best 500 runs or 2,000 runs to fill that multivariate space. Run the model in an automated fashion, pull those results back, and then run those through statistical analysis techniques. How complex is it? It's hours or a couple of days worth of work rather than months of work. But yeah, it's very doable. To your second question, what do you do about process data? Does Clarity clean it up and handle it? There's multiple levels of ways in which to answer that. Yes, Clarity. So as the data comes into Clarity, it'll check to make sure that it's in a valid range. It's matching the feasible units. It's doing what's expected. If the equipment has frozen or the data is not moving, it can spot those sort of errors. So you get the data coming in that basic clean fashion. Once it's in Clarity, then you can also look at it and play with it a little bit to try and if there's more complex interactions that you want to worry about. So for example, you might say, look, if the amperage being drawn or if the valve on the inlet to a compressor is closed, then the inlet pressure downstream of that valve to the compressor is probably not all that relevant. So you can have inter-variable dependencies like that. So you can start trimming out data in that fashion too. So it's quite a powerful environment for cleaning up data.
Great, Charles, there are a couple of questions in the Q&A. Can you say that at the bottom of your screen? Can you?
I am pulling it up now. I'm having a hard time finding them, maybe, sorry.
Okay, so let me just read this. So with everything available on the internet, is there really still a need for subject matter experts?
Yeah, that's an interesting one. There is, yeah, the internet is a fabulous thing. There's more and more data out there. There's more and more information, and it's increasingly easy to find vendor spec sheets or tools that people have developed to do complex analyses for you. Certainly, that's a great resource that's available. I think the problem, though, is you can spend an awful lot of time digging through and trying to curate that information. There's no easy way to really, just because you find it on the internet doesn't necessarily mean that it's real or that it's doing exactly what you're interested in. There's also quite a lot of information that remains, just either it's obvious to those in the field and so you don't bother writing it down, or it's non-obvious and proprietary and so you don't write it down. I think there's still definitely a role for that subject matter expertise, and I think that's one of the really powerful things about the setup that Crowley has created. It's got those people with 20, 30 years experience in certain areas to be able to keep up to date with what's the latest happenings in the industry, what's new and exciting in the world of air compressors, but also what are the rules of thumb, what are the best practices, what's the standard way of doing this, so that I don't have to go off and learn from scratch. So I definitely think there is still a role for people who know what they're doing.
Another one here. Machine learning is developing rapidly today. Do you think it will supplant mechanistic modeling very soon?
It's certainly all over the news, isn't it? Machine learning, artificial intelligence, neural networks. all the data is in the cloud, right? It's certainly making some really amazing strides. There's some really good things that you can do with statistical analysis and with data regression. That said, I mean, I think there's nothing new under the sun. I think the first time I came across neural networks is when I was an undergraduate. There was one of those fabulous old BBC News or Pathé News reels, black and white, where the boffins at top university were regressing using this fabulous new tool, neural networks, and they'd analyzed a series of pictures and were successfully differentiating pictures of males from pictures of females. And it was all working really well until the machine was shown a picture of the Beatles, at the time when they had long hair, and they decided, oh no, the Beatles are girls. You know, it's laughable, but you know, the thing about some of those techniques is they key on specific data, and it's all about the data that you feed into the systems. You think it's laughable that would happen, and the Beatles would be identified as female, but the sad thing is today people are using statistical analysis and feeding in crime statistics and reinforcing the skin tone issues, or HR firms are using it to look at salaries and reinforcing the gender pay gap. The thing about statistical analysis is it's all about the quality of the data and the sort of hidden bias, the clustering that's in the data that you use to develop those statistical analyses. So there's definitely great strides, and there's definitely times where it's useful and applicable, but there's also some real nasty pitfalls that if you're not really paying attention to them, can jump up and bite you. In the world of process simulation or process data analysis, it's very common that you have operating data in two regions. You have, you know, this is my my system running at full rate. This is my system running with one of the reactors turned off, so I'm at half rate. There's a strong tendency to try and find a correlation that fits across all that data. And if you try and fit in that middle region where you don't have very much data, a lot of these techniques are very high order regressions. And so you can try and optimize and find yourself in that middle region where you actually don't have very much data and really cause yourself some trouble. So I think what's quite powerful these days, if you look at some of the cutting edge research and some of the stuff that we've been doing, is to sort of try and have a hybrid model where you have the structure of your mass and energy balance constraining your system, and then you're using data analytical tools to try and interpret what's going on within that constrained environment. So rather than, it takes a lot of time and effort to try and maybe build a detailed model of how mixing is happening inside of your bioreactor or your
Charles,
system. Yes.
I have a couple more questions. I have
Okay.
another one.
I'm sorry, I'm waffling, am I? I'll shut up.
So my EMPIs vary depending on products and processes. Can Clarity define these better, and can it predict these based on predicted product runs?
That'll depend a little bit on exactly the process and the products, but yes, I mean, if you've got if there is a quantifiable difference that you can get at through the either the mechanistic understanding of how the process works under different conditions, or how the different products use the equipment, you can get at it through a mechanistic approach. If you've got good plant data, where you've got, I say plant, if you've got good data, it could be from your plant data historian, or it could be from your quality management system, or various other databases that you could feed in. If there's correlation to be found between the performance and the product process mix, then yes, that's something you can start bottoming out with Clarity. The devil is always in the details, but it's there's one client we're working with at the moment where they have they have multiple compressors feeding one end of the process. They've got a range of different products coming out at the back end of the process, and depending on which machines they make those products on and what mix of products that they're making, that really impacts how the compressors work. And yeah, we've been doing some fun work trying to marry up those two pieces of information, and it's early days, but it's starting to indicate that there's some real opportunities there.
Great. I have another one here. The reporting requirements for my sustainability metrics are really specific. How can a generalized tool that's looking at yield as well meet my needs?
Yeah, that is always a challenge, isn't it? I think though, the nice thing about the flexible environment that has been set up here is that because you're drawing data from multiple different sources, but you choose how to cut and paste, how to parse that data, how to put it together. So we've got several clients now who are doing a really nice job of replacing older techniques where, as I say, they would pull data from multiple sources into Excel spreadsheets or Google Sheets to try and build these reports. Some steps automated, some steps manual. Some challenges if issues crept in with missing links or overwritten links. And those reports are now being generated automatically by Clarity to the right standards in the right format. And what's nice is that once you get that nailed in and done, you know, it's a button click away every time you want. So you can move from doing it maybe once a month to doing it every day if you want. You still can roll it up and consolidate it for the month, but you can see intra-month how you're tracking against some of those metrics and how it's performing.
Another good one here. Some of my colleagues are proficient at building models. Can I use models previously built and plug their output myself into your platform, Clarity? Or is this an action you or your team would have to do for me?
It can go either way. It sort of depends. I'm sorry, that's my answer to everything, isn't it? It depends a little bit on what software and what tools and capabilities you have in-house. There is nothing that would prevent you from doing it yourself if you've got appropriate statistical analysis tools. So either you could do it completely independently, or we could help put together that space filling design. But at the end of the day, one of the real powerful features of Clarity, and at some point, if you're interested, we would love to do a demonstration. Essentially, what you do is you build that correlation. You say the total energy use on my plant is a function of the amount of product A I'm making, the pressure of the reactor, and the raw material moisture. You build that correlation either from process data or from a mechanistic model that you have in hand, and then basically you sort of connect in the Clarity platform. This is the tag that describes product moisture. This is the tag that describes the amount of product A that I'm making, and that's it. You can certainly do that independently, and we encourage most of our customers to do that independently. So the answer is either way would work, but there's nothing that will prevent you from doing it yourself if you've got the appropriate tools.
Somebody has just typed Aspen Pro.
Aspen Pro. I'm not sure.
Okay. Has anybody got any more questions for Charles? And just to let you know that we will be sending out the responses to all your questions as part of a follow-up afterwards. Are there any more questions? Okay. Will we wrap up, Charles?
Yeah, I think so. Thank you very much indeed for your time. I hope it was useful. Please feel free to ping any questions to me or to Crowley more broadly. I think there's some really interesting opportunities out there. I think this this marriage of the data with the mechanistic and process skills is one that will bear a lot more fruit as time goes forward.